Hello everyone, welcome to our channel Easy Explanation. In this video tutorial series of object-oriented programming using C++, following are the topics that I will be covering. These are constructor, types of constructor. So the types of constructor are default constructor, parameterized constructor, copy constructor, and finally destructor. So let us understand these topics one by one. So the first topic is constructor. What is constructor and why it is required? So constructor, it is a special member function that get called automatically when an object is created. It is a special member function, so constructor should be declared as a special member function while writing the class. If constructor is not declared, then our compiler will automatically create a constructor and call it. So these are the things related to constructor. It is a special member function that get called automatically when an object is created. So we can explicitly write our own constructor, or if the constructor is not given in the given program, then our compiler will automatically create a constructor and call it when an object for that class is created. So these are the things that you need to remember, and some other points that you need to understand about constructor are, so some points are: constructor will have same name as class name. Since the name of constructor will have a same name as a class name, it is called as a special member function. And another point is constructor should always be declared in the public section. So one more thing that I want to discuss, that I have discussed above, is like when constructor is not given in the class, and constructor is not given in the class, or you have not written your own constructor, then compiler will create a constructor and calls it automatically. So you have not, if you have not written any constructor in your program, then compiler will automatically create a constructor and call the constructor when you are first creating the object. So this is another point that you need to understand. And another thing is, obviously, so you can create your own constructor for the given task. So this is the explicitly part, means you can explicitly write your own constructor. If you are not writing your own constructor, then your compiler will implicitly or automatically create a constructor and calls it. So these are the points you need to remember related to the constructor. Now let us write a simple program to understand the concept of constructor here. So sample program to understand the concept of constructor. has include IOString using name space std, and finally the main function, and write return 0 here. Now let us define a class. So class or something like this, constructor demo, or simply write the class as a demo class, class demo, and int x, let us say it as just a single member variable as x. So we have created a class called as a demo with just a member variable x here. Now let us create an object related to class demo. So demo d. When you run this code, so no such files or directory, compilation terminated, it is throwing us an error. So what I have done is I have declared the file as a program2.c. so .c is the extension to C programming language. So what we have to do is we have to save it with .cpp extension. So program2.cpp. Okay, now let us save it again and run the code. So there is a spelling mistake, I think, NAMES. Okay, now it is correct. So you have to look out for that thing. So you can see now there is no error in the code and the program has been successfully compiled and executed. So let's see. So program starts, or execution always starts at the main function. So in the line number 11 we have demo d. So demo is the class name and d is the object that we are trying to create. So when an object is created, constructor is required, but in the class demo we have not mentioned any constructor. So here automatically our compiler will create a constructor and calls it. So in this case, constructor is automatically created and called by compiler. Since we have not written our own constructor, our compiler will create a constructor and call it whenever the object is instantiated. So this is the thing that you need to remember. And we can also write our own constructor also. We can also write our own constructor, and constructor should always be written in the public section. So write public, and since the constructor is a special member function, means constructor will have a same name as a class name. So the name of constructor will be demo, and since it is a function, we have to write like this and write the body for the constructor here. Now we are creating our own constructor, so I'll write cout constructor is called here and L. Now we have written our own constructor. Now let us compile this code. Now you can see how the program runs. So the entry point of program, line number 13, main function, go inside the main function. In line number 15 we are creating an object here, demo d object for the class demo. So whenever the object is instantiated, constructor is called. Since we have written our own constructor, the program control transfers to line number 8 now. In line number 8 we have our own constructor and the body of constructor is executed, and there we have a print statement, constructor is called here. So you can see the output as a constructor is called here. You got the output. Once this is done, the program is terminated. So in this case we have written our own constructor. So we have written our own constructor. So if the constructor is not mentioned in your code, our compiler will automatically create it and call it, and obviously we can write our own constructor to do some special task there. So this is the concept related to the constructor. Now since constructors are called when the object is created, so we can use the constructor to do some special task in the C++ program or in any object-oriented programming language. So since constructor get called when an object is created, then why not to use constructor to initialize the object. So since constructor is automatically called when an object is first created, we can use the constructor to initialize the object. So that is one of the major function of constructor in C++ program or in any object-oriented programming language. So one of the major function of constructor, so one of the major function of constructor in C++ programming language is to initialize the object. Initialize the object at time of its creation. Initialization of object means, now since there are member variable related to the object, why not to provide the value to that member variable? So that is one of the major function or task related to the constructor, to initialize the object at time of its creation. What is the meaning of this? Let us understand it programmatically. Now we have a member variable x here, or data member x. So why not to use the constructor to initialize the value of x here? So we write x is equals to 10. X is equals to 10, and I write another function, void display cout, or simply return x. Since we are returning the values, the return type of function, member function, will be int. This is not required. This I will remove this comment line now. So an object is created. First an object is created. At the time of object creation, we will call the constructor, and when the constructor is called, what we have done in the body of constructor is we have initialized the variable x with the value 10. So at the time of creation, the object is initialized. Now we can call the value or display the value which is related to the object d. So we can call d dot display and see, we have got the value as a 10. So at line number 21, object is instantiated, means at when the object is instantiated, constructor is called, x is assigned with the value 10, and the print statement constructor is called is printed here. And whenever you call the object, call the function display with respect to this object d dot display, its member variable which has a value of 10 is displayed. So return x has a value of 10, so it displays the value 10 here. So in this way the constructor works in C++ programming language or in any programming language. So now the major task of constructor in object-oriented programming language is to initialize the object when it is created. To initialize the object when it is created, this is the thing that you need to remember. Now based on this concept, we have mainly three types of constructor that you need to understand. The types of constructor are, so types of constructors are, one is default constructor, another is parameterized constructor, and the third one is copy constructor. So let us understand this concept one by one programmatically. For that, I will create another file, save it with obviously .cpp extension, so prog3.cpp. so sample program to understand the types of constructors and their uses. So has include IOStream, name is SPSE std. Let us write a simple program for that. First I will declare and define a main function, int main, return 0. Let us say I have written a program or create a class called as a shape, class shape. So the class shape will have two attributes, int length, int breadth. So we are talking about a shape that will have length and breadth, with measured two sides, length and breadth. And so let us create the object of class shape, shape rec, let us say. Shape is rectangle. Let us create a rectangle object. I have mentioned it as rec, and shape is a class name. So shape rec. Now let us define or declare a constructor. For that, write a public label. So the constructor should always be declared as a public. So shape, we are calling a constructor here, and length is equals to 10, breadth is equals to 20. Void display or area, let us say. So int area, return length into breadth. So cout area is equals to rec dot area and indel. So let us run this code. So the area is 200 here. So how this program works and what is the default constructor, that is the thing that we are trying to understand here. So first start with the main function. In the body of main function, line number 21 is first executed. We are creating an object rec of type shape. So when an object is created, constructor is called. So control transfers to line number 9, and the constructor is get called here. In the body of constructor, we have initialized the value of length equals to 10 and breadth is equals to 20. So for rec object, so for the object rec, we have length is equals to 10 and breadth is equals to 20 over here. So object is initialized when it is created. So that is the use of constructor that I have mentioned above. Now once the constructor is initialized, whenever the object is initialized, in the line number 22 I am calling the function area with respect to the object rec, and it is returning length into breadth, and length into breadth returns the value of 10 into 20, which is 200, and we got the result as a 200 over here. Now you can see in this program we have this first constructor. The constructor declared here is called as a default constructor. So in this case, this constructor defined here become default constructor. So shape is a default constructor, so it get called automatically when the object is created, and we are not passing any type of argument to this constructor. Since this constructor do not have any argument over here, it is called as a default constructor. It get called automatically when the object REC is created. We can also create a constructor with some parameter beneath, so which is called as a parameterized constructor. So parameterized constructor. For that, we create a constructor first. Now again, it is example of default constructor. Since we are not passing any parameter, if we pass any parameter to constructor, it became parameterized constructor. I'll write int l comma int b. Now we initialize the value length is equals to l and breadth is equals to b over here. So we have defined a parameterized constructor. Now let's write or create another object sq with value as a 10 comma 10 and area is equals to sq comma area. Now let us see the result. So for line number 30 we have got the result as area is equals to 100. So in this case, when the object sq is created, we are creating the object called as a sq with a value 10 as 10 and 10. So when sq of 10 and 10 is called, the constructor with a parameter is called here. So parameterized constructor get called, in which 10 get assigned into L, another 10 assigned into B, and its value will be assigned into length and breadth. So we have a SQ with length is equals to 10 and breadth is equals to 10. So SQ length is equals to 10 here and breadth is equals to 10. So this is the example of parameterized constructor. So in the like if you are passing any value to the parameterized constructor, you can follow this convention or syntax. Since we are not passing any argument over here, the default constructor get called for REC, and since we are passing some argument here, the parameterized constructor get called for SQ. So to create the REC, default constructor get called, and to create the SQ object, parameterized constructor get called. So this is the thing that you need to understand, and these are the example of default constructor and parameterized constructor. So in default constructor, we will not provide any types of argument to the constructor. In parameterized constructor, we need to provide a parameter to this constructor, and in this case our constructor is overloaded here. So there is also concept of function overloading or constructor overloading over here. So now another constructor that we need to understand is copy constructor. So what is the use of copy constructor? First we need to understand that. So copy constructor is used for cloning an object. If you need to create a clone of object of given object, then you can use the concept of copy constructor. Let us say for the shape class, shape ob 10 comma 20. In this case, we have created an object ob over here. We have created an object ob. Now let us say in this case, this ob will have a length of 10 and breadth of 20. Now let us say I want to create a clone of this object ob, another object with same length and same breadth. For that we can use the concept of copy constructor. So let's write or understand this concept programmatically over here. So let us understand this concept of copy constructor programmatically. Before understanding the concept of copy constructor, I will tell you one more concept of simple program with function. In the function will be called as a call by reference. So let us understand the concept of call by reference first, then we will be discussing the concept related to copy constructor. For that, I will be creating one more program. New source file save as prog4.cpp. Concept of call by reference. Include IO string, space std, int main, return 0. Let us say I have a function called as a void duplicate, and we have a value int a is equals to 10. Let us call this duplicate method with value a, and in the duplicate method we will be creating a reference for the variable a. So how to create the reference for the variable a? What we'll do is int %b. In this case we are creating a reference for the variable a, which is b, here in the duplicate method. And what we'll do is b is equals to b into 2. So cout value of a is equals to a and l, and after calling the duplicate method, let us again print the value of a. Value of a is equals to a. So you can see first it prints the value of a as a 10, which is the initial value of a, whenever I call the method duplicate, and when the line number 2 is executed, the program control transfers to line number 4. In line number 4 it creates a reference for the variable a. Another variable b is created, and in the line number 6 what we are doing is we are just multiplying the value by 2, and the value get multiplied by 2, we got the result as 20. So in pass by reference or in call by reference, what we'll do is, what we are doing is a call by reference, the syntax, let us say we have int a is equals to 10, and whenever we do something like this, int %b is equals to a, something like that, a reference for the variable a is created. So in this case we have a is equals to 10. When this line is executed, whenever you do something like this, whenever this statement get executed, we create another variable, and this variable also points to the same location. Now for the one location with the value 10, we have two variables created, a and b, which are pointing to the same location with value 10. So that is the use of this syntax, so do not get confused. So we are just, what we are doing is we are just creating a duplicate or a copy of variable a over here. It means the value 10 or the location in which we are storing the value, or we have stored the value 10, is referred by the name a and b. So a and b both are referring to the same memory location with value 10. So this is the use of call by reference. We'll be using the same concept to understand the concept of copy constructor. So do not get confused by this ampersand symbol. It is just used to create reference for the given variable. Now once you have the idea of what is called by reference, let us understand the concept of copy constructor. And let me remind you again, copy constructor is used for cloning an object, or to create a copy of an object, or to create a clone of an object. So what I'll do is I'll create in the same program, I'll create a clone of this square. I'll create a clone of this square. So for that we'll create a clone of a square object. So shape clone clone is equals to, or clone underscore sq is equals to sq. So in this case copy constructor is called. And what is the syntax of copy constructor? So the syntax of copy constructor is, first create a constructor. This is the body of constructor. Now we have created a default constructor. To make this constructor as a copy constructor, what you have to do, write the keyword const constant. Let us create a constant reference variable, then write the class name, and then write the object name. So we are creating a reference to sq variable, which is the obj. Now obj variable and sq variable are both referring to the same object. So over here we have a sq object. We have a, this is the actual object with length is equals to 10 and breadth is equals to 10. In this case a variable called as a sq is referring to this location. And whenever you call this shape clone underscore sq is equals to sq, then a copy constructor get called, control transfer to line number 20, and we are now creating another reference variable for sq object. Now there is another variable obj created. Now this obj is referring to the location sq, means location pointed by sq. Now what I'll do is length is equals to obj dot length and breadth is equals to obj dot breadth. I can see sq and obj both are pointing to the same object with length 10 and breadth 10. Now we are calling copy constructor with reference to variable cloned sq with respect to the object cloned sq. Now another object cloned sq is created with length and breadth as a member variable. Now I can see whenever this line gets executed, then obj.length returns 10, which get assigned into variable length of cloned sq. So length is equals to 10, and obj.breadth returns 10, which get assigned into breadth is equals to 10 over here. So in this case we have successfully created a copy or a clone of the object sq over here by using a reference variable obj. So in this way copy constructor are used to create the clone of a given object. So now we have a two object, one object sq, another object clone sq with the same dimensions. In this way the clone can be created by using the concept of copy constructor, and whenever you print the value of its area you will get the same result as 100 over here. Area is equals to clone underscore sq, and whenever you execute this thing you can see we have got the same result, area is equals to 100. So by using the concept of copy constructor we have successfully create a clone of sq object of type shape. In this way the copy constructor works. So this is the whole code, and this is the everything related to the concept of constructor. So The first is default constructor, the second one is parameterized constructor with parameter passed into constructor, the third one is copy constructor, and the fourth one is obviously a member function. So we have created in line number 33, we have created two objects, rec. For that, default constructor to get called, for sq parameterized constructor get called, and for line number 36 copy constructor get called over here. So this is the concept related to the constructor. Now we have another concept called as a destructor, the final concept. So what is destructor? So similar to constructor, destructor, so destructor get called automatically when an object goes out of scope. Now see, when an object is created, let us say save obj. So we are creating an object called as obj. So creating an object or instantiating an object means we are allocating some space in the memory for the object. So an space is allocated for the object. Now once the task of object is done, what we need to do is we need to free the memory allocated for that object. Once the object is done or the task performed by the object is done, so what we have to do is we have to deallocate the memory that is allocated for the given object, and the deallocation is done by the concept called as a destructor. The deallocation of memory allocated for the object is done by the concept called as a destructor. So by default our compiler will call the destructor when an object is destroyed or when an object get out of scope, or we can write our own destructor similar to the concept of constructor, and we can define some of the functionality if required. And the syntax of destructor is we can use this tilde symbol and the class name and this thing. So this is the way to declare the destructor, tilde symbol and class name. So let us write a destructor. So most of the time destructor get called when the object is destroyed or when the object goes out of scope or when there is no use of the object in the given program. So how to write the destructor? First you have to use the tilde symbol and write the, I'll declare it over here just after the constructors, tilde symbol and name of class, and use that symbol and write the print statement cout. Finally destructor is called email, and let us see the result. So compile and run this code. So see, we have how many destructor called, finally destructor is called, finally destructor is called, destructor is called. So our destructor is called 3 times. Why destructor is called 3 times? So since we have created 3 objects, one is rec, so when the rec goes out of scope, its memory is deallocated by its destructor, and destructor is called and it prints destructor is called statement. And another object we have is sq object. When the sq object goes out of scope or where there is no use of sq in the program, its destructor get called, so destructor is called finally. And we have a last object called as a cloned sq. For cloned sq also the destructor get called, so destructor is called, this statement is executed. So we have got 3 print statement for 3 object. So one and only use of destructor is to deallocate the memory or spaces or resources allocated for the object. So one use of destructor is to deallocate the spaces or resources allocated for the object. So the use of destructor is to free spaces allocated for the objects. So our destructor will call as many times, means the number of times the destructor get called is equals to number of objects created in the program. So this is all the concept related to the constructor and destructor. I hope every one of you understood the concept. If you have any query related to constructor or the topic that I have already discussed in this series, please mention in the comment section. Thank you so much everyone. If you have not subscribed to our channel, please subscribe, and if you have any query, please let us know. Thank you so much everyone. Bye bye.